Hello everybody, this is Saif Habashi. In this video, I'm going to discuss two ways of proving the product rule for derivatives. This is the first way. So the first way, we start by defining the function f of x, which is defined as g of x times h of x, where h of x and g of x are functions of x, obviously. The derivative of f prime of x, is equal to the limit as delta x goes to 0 of g of x plus delta x times h of x plus delta x minus g of x times h of x divided by delta x, right? To be able to move on, we need to add something and subtract it again. What do we add? We add g of x plus h times h of x and subtract it again. X plus h of x. Sorry, g of x plus delta x. All right. Delta x. So, what do we get from adding adding this thing and subtracting it again? Here we have g of x plus h, g of x plus delta x, and here we have g of x plus delta x. So we take it as a common factor. What are we left with? H of x plus delta x and h of x, and will be divided by delta x. And you see where this is going, right? So we move on by taking g of x plus delta x as a common factor from here and taking h of x as a common factor from here, right? So let's start with the first part, which is, so f prime of x is equal to the limit as delta x goes to 0 of g of x plus delta x times h of x plus delta x minus h of x divided by delta x plus. You see, we're going to take h of x as a common factor from here. So h of x times g of x plus delta x minus g of x and divided by delta x. All right. What is this? This is h prime of x. What is this? This is g prime of x. And we are done. We are basically done. So the limit as delta x goes to 0. Here we're left with g, and this is h prime, and this is h, and this is g prime, which is our product rule. So f prime of x is equal to g of x h prime of x plus h of x g prime of x. Cool, right? This is our result, QED. Second way is, we first start by defining the function y equals u times v, and the different attack for the problem here is that we don't use the original definition directly. We say that we change x by very, very small change, delta x. So x, every x, becomes x plus very, very small change, delta x, right? So this change in x would result in a change in u and a change in v and also a change in y. So y plus some delta y is equal to u plus delta u times v plus delta v. We multiply this out, we get that y plus delta y is equal to uv plus u delta v plus v delta u plus delta u delta v. All right. Here, you see where the product rule would come from. You see uv and y are equal, so we subtract it from both sides. So delta y becomes u delta v plus v delta u plus delta u delta v. So we divide both sides by delta x, which is the original change that we changed by x by. So we divide by delta x here and here and here and here. So then we take the limit as delta x goes to 0. What happens? The limit as delta x goes to 0 of delta y over delta x both go to 0. This is a trick because when I first saw this thing early, from probably 5 years 5 years from now, it was weird. I thought, what? Delta x is on the denominator, so as delta x goes to 0, so this would give infinity. But delta y is also going to 0, so 0 over 0 is an indeterminate form, so the limit might exist, and hence this is dy by dx. This is equal to u times dv by dx plus v times du by dx plus the limit as delta x goes to 0. This means that delta v goes to 0, so plus 0. So we are done. This is the product rule for derivatives. Don't forget to subscribe, like the video, and share this video with somebody who would be interested. And goodbye.